and go for it.
Good afternoon, Mr. Cloutier.
Hi.
And my name is Nicolette. And we are grade 6 students at Christ the King Catholic Elementary School. We are so excited to speak to you today about exoplanets. To begin, could you please tell us a little bit about yourself and how you became involved in the study of exoplanets?
Okay. So yeah, my name's Ryan. I'm a fourth year PhD student in the Department of Astronomy and Astrophysics at the University of Toronto. So a little bit about me. I'm really old. I'm like 26 now, and I've been doing astronomy for I guess since I was about 20, so for about 6 years now. And the way that works is like you guys, I did my grade 6 all the way up through high school. I did a lot of science in high school and ended up getting a degree in physics from the University of Toronto, which is a bachelor's degree, which is a 4-year degree. And right after that, I jumped right into doing a PhD in astronomy, which is, all of astronomy. But when I was an undergrad, I took courses in astronomy, and I thought one of the most interesting parts of all of astronomy to me was exoplanets. And so when I went straight into grad school to do my PhD, I thought exoplanets was the thing I wanted to pursue. And here I am 4 years later, still think they're really cool.
Thank you. Thank you.
Hi, I'm Eddie.
Hi.
We've learned a little bit about exoplanets in class, but can you please help us understand better by briefly defining an exoplanet?
Sure. So you guys all know about planets, I assume, right? We're standing on one right now, and there are only 8 that we know of. And when I say there's 8 planets, I mean there are 8 planets orbiting our sun, right? So the sun that you guys see in the sky is a star, and it's our star. But the galaxy that we live in has about, 100 billion other stars. And so you can imagine that those other stars also have planets that orbit around them, just like the planet that we're on now. Those are exoplanets. So they're just planets, but they orbit around stars other than our sun. And there are 100 billion other suns in just our galaxy. And don't even get me started on the number of galaxies, right? There's billions and trillions of other galaxies. So many, many, many other planets around other stars that we call exoplanets that we hope to find and really to study.
Thank you.
Yeah.
Hi, I am Ben.
Hey.
What are some techniques that you use to detect exoplanets?
Okay. So there's a bunch. There's a good handful. So maybe I'll just talk about maybe the most important one to start. So you can imagine my head. I don't know if everyone can see my head, but imagine my head is some star, hundreds of light years away. And imagine that the star that is my head has a planet that is my fist and goes around, right? So the planet just orbits around the star. So if you take your camera and you point it at the star that is my head, and you just keep taking pictures, and you basically monitor how bright my head is over time. Eventually, if a planet comes in front of my head, it blocks some of the light from my head, right? So you see, if there's no planet, you just see consistent brightness. I'm always the same brightness. But as the star comes around, it blocks some of that light, and you see a little dip in the brightness. The star gets a little bit dimmer. And as the planet goes around, you see dimmer, dimmer, dimmer. And so if you see those little drops in light, you can basically detect a planet orbiting around the star. And you can tell how big it is basically by how much dimming you see, right? So a really big planet is going to block a lot of light, but a really tiny planet is only going to block a little bit of light. So you can detect the planet, and you can tell how big it is.
Okay, thank you.
Yeah.
Thank you.
Thanks.
Hi, my name's Tiffany, and my question is, have scientists found an Earth-like exoplanet? What characteristics would make a planet Earth-like?
Sorry, I missed. Can we find an Earth-like planet and?
Read it again.
Have scientists found an Earth-like exoplanet, and what characteristics would make a planet Earth-like?
Ah, okay. So that is a really interesting question. So first of all, if you want to be really, really Earth-like, then you've got to be the same size as the Earth. And again, we can measure the size because of the dimming. But you also have to be orbiting around a star that is basically like the sun. And most stars in the galaxy are not like the sun. Most of the stars in our galaxy are a lot smaller than the sun. And it's actually easier to find planets around those smaller stars. So most of the planets that we know about are around stars that are not like the sun. And so those planets are not really Earth-like, right? So there are maybe 2 or 3 planets that we know of that are about the size of the Earth. They orbit around a star like the sun, and they have an orbital period or a year that's about the same as the Earth, so about 365 days. Give or take a few tens of days. But those are the planets that we call Earth-like, or the most Earth-like. And there's a small handful. I mean, I could probably count them on one hand. But if you want to talk about planets that are now the size of the Earth, but are around smaller stars, we might still call them Earth-like, because imagine a smaller star is not as hot as the sun. If it's smaller than the sun, it tends to be a lot cooler than the sun and a lot smaller. And so if you want to have the same temperature that we have today, a few tens of degrees Celsius, maybe room temperature, if you're orbiting around a star that's a lot smaller than the sun and therefore a lot cooler, instead of the star being here and the Earth-like planet being way out here, because the star is colder, you have to move this planet in. So an Earth-sized planet, but on a very small orbit. And those we know of a few tens. So actually quite a few.
Wow.
So really the answer to your question is, how technical do you want to be when you ask about an Earth-like planet? Because if you want to include all stars, then there's quite a few more, but they're all on very close orbits that are like a month long instead of 12 months long.
Thank you.
Yeah? Okay, thanks.
Thank you. That was great.
Hi, I'm Sophia. My question is, how many exoplanets reside in our galaxy, and how many possible exoplanets are in our galaxy right now that haven't been confirmed yet?
That haven't been found yet?
Confirmed.
Confirmed yet? Ah, okay. So, sorry, the first part is how many are in our galaxy?
Yes, how many exoplanets reside in our galaxy?
Okay, so right now we only know of about 4,000, right? And those are 4,000 that we've actually found. But I think I said before that there are 100 billion stars in our galaxy. And you can imagine sort of as you get further and further away, right? So the stars immediately close to the sun are sort of the easiest ones around which we can search for exoplanets. But the ones that go really, really far away, it's much, much harder. But if you just take the 4,000 that we know of, which are in, this small population of stars that are close to our solar system, you can measure the average number of planets per star. And it's about 1. So on average, every star has about 1 exoplanet. So then if you just extrapolate out to all the stars in the galaxy, you get about 100 billion planets in our galaxy. But we only know of about 4,000. Yeah, sorry.
Hi, Ryan.
Hey.
I'm Alexander, and my question is, do exoplanets have any other significant meaning other than being habitable?
Other than being habitable?
Yeah.
So most exoplanets aren't habitable, actually. So exoplanets is really just any planet around another star. But of the 8 planets in our own solar system, only 1 is currently habitable. But we still call the other 7 planets, just like we call all exoplanets planets. A very small subset of them are going to be habitable, meaning that they have the right sort of temperature of, a few tens of degrees, room temperature-ish, That's what we're going to call habitable. But really, most exoplanets aren't habitable. Most exoplanets that we know of are really, really freaking hot. Way too hot to be habitable. Does that make sense?
Yeah. Just to clarify it, I mean, why do you study them?
Yep. Sorry?
Why do you study them in different? Is there any different ways you study them?
Yeah. So if most of the exoplanets that we know of aren't going to be habitable, they're still interesting to study because we really want to know how these things form, right? We want to know where these planets come from. Do they all form and create things that look like the solar system, or do they form by different pathways and create things that don't look like the solar system? And so by studying all the kinds of exoplanets, whether they be habitable or not, we can start to find clues of basically how these things formed. And from that, you can start to infer whether or not Earth, arguably the most important planet, whether or not the Earth is something that's very common or something that's very rare based on how it formed.
Thank you.
Thanks.
Thank you.
Go ahead.
Hey, Ryan. Here's my question. How far is the nearest exoplanet?
The nearest exoplanet. So actually, I think it was just last summer. Yeah, it was last summer that we found an exoplanet around the nearest star to the sun, which is about, I think it's about 4 light years away. So the nearest star is 4 light years away, and so therefore the closest planet, because it's around that star, is also 4 light years away. Do you know what a light year is? Do you guys know what a light year is?
Can you explain for us?
What's that?
Can you explain for us?
Right. So just light, right? Like just like light that you receive from the sun, it travels very fast, but it has a speed, right? And it's a very, very fast speed, but it is a finite speed, just some number. And because the sun, our sun is so far away from the Earth, it actually takes light from the sun 8 minutes to go from the sun to get to Earth, right? So it's 8 light minutes away.
Oh.
So a light year is just the distance it takes light to travel for a year. So basically that star and that exoplanet, that's the closest one to our solar system, is 4 light years away.
Wow.
So if you shine a flashlight at that star, it's going to take 4 years for the light from that flashlight to reach that star.
Wow.
That's how far away it is.
Thank you.
Thank you.
Thanks.
Hi, Ryan.
Hey.
I'm Isabel, and I want to know why are exoplanets called exoplanets?
Why are they called exoplanets? Oh, so this is a weird linguistics lesson now, right? So if, I didn't study Greek, and I think it's Greek, but basically the prefix exo just means outside, right? Like exterior means outdoors or outside, and planet, as far as I know, just means planet, right? Some rock orbiting around a star. So exoplanet, outside planet, basically just means planet outside of our solar system.
Thank you.
Thanks.
Hi, I'm Kira. Even though you don't study this, what do you think is the future of space travel?
Ooh, okay. So do you mean 2 exoplanets, or do you mean like to the moon or to Mars?
Just like all of it.
All of it. Okay, so things like going to the moon, and which we've done a number of times back in the 60s, 70s, and 80s, I think, was something that humans set out to do, and we did it. And so I think now, if we're going to do more, the next place we need to go is Mars, which is the next closest planet, right? So it goes Mercury, Venus, Earth, Mars. I think if we're going to travel to another planet, the next place we're going to go as humans, the human race, has got to be to Mars. And it takes many months to get there, right? It's a long journey. And then, once you get there, do you try and land on the surface of the planet, or just orbit around it a few times and come back? It's a difficult problem, right? And so the issue with trying to visit exoplanets is that, again, they're years away, right? They're light years away, And our spacecraft don't travel at the speed of light. They travel many, many, many times slower. So sending humans to, say, another exoplanet is going to take, tens of thousands, if not hundreds of thousands of years. And of course, humans don't live that long, right? So trying to conceive how you're going to send the human race to something that's so far away is a bit of a technical problem and a biological problem, right? Because you need to basically sustain a human-like civilization, but on a tiny spacecraft moving at thousands of kilometers per second through the universe. It's a difficult problem, and one that I don't think is going to be addressed, at least not in my lifetime, and unfortunately probably not in yours either. But we can hope, and there's people thinking about it, so we're on the way.
So interesting. Thank you.
Thanks.
Okay, Nicolette.
Okay. On behalf of both grade 6 classes, I'd like to say thank you for taking the time to share your knowledge and insight with us. We learned so much today.
Perfect. Thank you guys so much. Thanks, guys. Lots of fun.
So much.
Thank you, Ryan.
Thanks, Robert.
Thank you.